I'm Eric, co-founder and CEO of Encord. Encord is an active learning platform for computer vision. We provide tools that help people developing computer vision models annotate, manage, and evaluate their training data and build active learning pipelines for their models. So I'm very excited today. Our guest is, again, Dr. Luc Vincent. Luc has had a storied career in computer vision, AI, and technology in general. So after completing his PhD in mathematical morphology, he served as a postdoctoral fellow at Harvard before entering industry. He started his career first working in the field of document compression and OCR in several tech companies, including Xerox PARC. He then spent over 12 years at Google, where among many other projects, he created Google Street View and co-led the acquisition and scaling of reCAPTCHA. He then transitioned over to Lyft, where he ran the autonomous driving division, Lyft Level 5, and oversaw the division's acquisition by Toyota for over $500 million. And now he is VP of AI at Meta, where he is leading many of the augmented reality initiatives, which we hope to get to within the talk. So Luc, thank you very much for taking the time. I know you're extremely busy. I'm very excited to talk to you.
Glad to be here. It's awesome to be able to sort of share my stories with this audience. So thank you for the invite.
Yeah, and I should also mention Luc is joining us from Wyoming. That's not a fake background. That's his real house. I think he has he's a very
the big whiteout right now.
You're right.
Yeah, it's an amazing place. Yeah.
So I thought I would organize the chat just by going chronologically. So going from the past to the present to the future, and centering around AI in your career, as you've seen a very long trajectory and have, I think, a very interesting perspective on AI and machine learning in general. And usually the best way to see the future is just to look at the past. So I guess my first question is really starting back maybe 30 years ago. And you've been involved with computer vision for quite a while. If you put yourself in your past self shoes 30 years ago, where would you be surprised about where we are today? So where do you think we've made more progress than expected and maybe less progress than expected?
Gosh, this is a tricky question to start. I think when I started my PhD work, which was in, as you pointed out, in mathematical morphology, which is like an approach to computer vision that involves shape used as probes in images. It was all very deterministic, approaches. It was very simple. It was all about try and error, trying different parameters, running parameters, seeing results. I'm seeing an echo here, but maybe it's just me. Anyway, it worked pretty well sometime, but it's very, very ad hoc. And what's surprising to me today is how incredibly general you can make systems that can, I don't know, for example, one big challenge I was involved in throughout my early career and my PhD was image segmentation, right? And one of the key things I contributed to during my PhD was a technique known as watershed segmentation. Again, very interesting approach for the time, but now I think there are many AI-based approaches to image segmentation that do so much better and so much more in a much more general manner. So this is what's surprising to me is how incredibly general the current approaches are compared to what we had 30 years ago. And there's probably many other things to say, but this is one that comes to mind. Yeah.
So it's a lot less heuristic, a lot less ad hoc. You can
exactly
a big neural network, kind of get to the right answer.
Very much so.
With which the progress was slower than you expected. That yourself 30 years ago, you would have thought, by 2023 we should have this kind of capability in computer vision, and we don't have. Or has it just been faster progress than you would have anticipated?
I'd say it's been maybe slower progress for the first. I don't know, if I look back at the past 30 years, maybe slower progress the first 20, and then the past decade, incredible acceleration because I think we were able to over that time demonstrate that by scaling data training, scaling model size, and creating deep neural nets, we could actually get to amazing performance. So scale of compute and of training data of size has unlocked amazing capabilities of today. right?
Yeah, and I'm actually very curious to get into that in a little bit. I think that goes to right before we started. You mentioned that you joined Google during the dark years of tech. So I'm curious what that was like and how that just manifested, what the general sentiment was in the field, at that time.
Yeah, no, actually, you're off by a few years. I joined a startup in 2000. Right, which were, I think, difficult years. Obviously, when you join at the peak, you don't know it, but it was a kind of a peak. And having a startup between 2000 and 2003 was very difficult. At some degree, we see some of this, today because of the current sort of market conditions. But in 2000, following the dot-com bubble bursting, it was quite a challenge. So then after that, actually, I joined Google, which had been surprisingly immune from this, this turmoil, and it was an amazing place to be at the time. So that was, as you pointed out, I was able to pick up a bunch of projects and sort of run them from, from ideas all the way to big things.
What was the company culture at Google like when you joined? What was it like just being there? Has that changed as far as you know since you left?
Yeah, so I joined Google when we had, it was 2004. We had about 2,000 employees. Maybe it was 2,000 engineers, and maybe it was 3,000 total. It was just bursting with energy and with optimism and ideas. And essentially every day you had the impression the sky was the limit. That you were there, you could sort of pick up any project, get make it happen, right? For example, it was like there were no budgets, there was no headcount tracking, no such thing. It was just about grabbing things, hiring as many people as you could, and making things happen as quickly as possible. So it's kind of a unique environment, which I think you don't get these conditions sort of very often, if ever. So it was a fun time.
Yeah, what was the lead time between you have some idea and then you actually implemented that idea in some condition, or that the public knew about it? I'm curious, because even now today, there's probably someone at Google that has some very interesting idea that we won't know about in, I don't know, 1-2 years. How long did it usually take to go through this entire cycle to get something in the real world?
Yeah, I don't know if there's like a typical time. I can tell you about my experience with Google Street View. So I joined in September 2004. I joined Google Books because I was, I had spent the early part of my career in the space of documents, OCR compression. So that ambitious project, Google Books, which aimed to scan all the world's books and make them available through the search index, was just incredible to me. So I joined that, but I realized over even my first week, maybe even my first day, that there were a bunch of other things I could be doing there. And I remember, in fact, I think my first day, after a whole day of orientation and meetings, I'm pulled into a 6 p.m. meeting by my then boss to talk about this idea that Larry Page had to put cameras on cars and try to see if that could lead to interesting experiences and user value. And that project didn't really exist at Google. There had been some funding to research team at Stanford, but that project didn't exist. So I became interested and understood how Google worked, understood the concept of 20% projects, which is the notion that every engineer, every manager can take a day a week, or I don't know, roughly a week a month, to work on something that they believe is matters, can have an impact for the company, and sort of try to make it happen. So I quickly realized that this could be one of those. I took this project, which we called at the time City Block, as my 20% project. And so how long did it take, to go back to your question? So I took it on, managed to get some, made some slow progress at the beginning because I was still getting going with Google. So it took me, let's say, 6 months to work on books, try to get something going with this project. Then over the first summer, I was able to attract 6 interns to work on it. And then another 6 or 7, 20%ers like me. So summer of 2005, we made a lot of progress. We built the first car, we built the first data pipeline, the first GUI, the first sort of end-to-end demo that this could work. And in the fall, I was able to then give a talk, a tech talk about the project, which internally, so nobody outside Google really knew about this, and that generated interest from many people who wanted to come and work on it with us, and then VP of Eng at the time thought it was useful and could be good. So late that year, I finally got some official funding and headcount to go faster. So meaning that the recruiters could be attached to me to actually bring people in. So that was late 2005, and so that's when it became real. And then it took another 5 quarters to actually launch. We launched in May 2007. So that's gives you an idea of the timeline. So
I mean, that's immensely fast if you think about all the components that are required. You'd have to have hardware on the cars, the data pipelines, the ability to process all the data, the software to render it. So the fact that it started from your first day at Google, it sounds like, to less than a couple of years later actually being in the real world is pretty amazing.
Yeah, it was fast moving. Yes, and we also wanted to go fast because we felt that there was some value in iterating quickly. So the motto at the time at Google was you launch and iterate. You rather launch quickly with something half baked and then iterate based on user feedback. I think they would do it very differently today. You can't afford as Google now to launch something half baked, I think.
Yeah, that's a very startup mentality. I mean, we say that all the time here as well. A common expression is that if you're not embarrassed by what you're launching too late, which we share. But it sounds like it's very interesting. There was no budgets, and from your story, it sounds like the main constraint was actually in attracting the internal talent. So getting the attention of engineers to actually join your project. Was there kind of like campaigns that were going to people?
That's right. It was internal and external, really. It was all about being able to staff quickly, and there was some competition. So the flow of engineers came in through the large recruiting pipeline, and you had to go and bid for the people that you thought were most appropriate for the project. And of course, you also could try to get people to join internally if they were more interested in your project than theirs. But yes, it was all about being able in the early days being able to build the dream team very quickly to be able to iterate quickly.
Yeah, it's all about time. And looking at Google Street View today, it's something that's used by millions and millions of people. I think while you were there, you launched it to over 75 countries, but now it's an even more. Did it surpass your vision? Did it reach your vision? Was there anything that you were surprised by in how it was kind of eventually realized in the real world?
At the very beginning, right, we all knew there was a risk, right? There was we didn't know, what the experience was going to look like. We didn't know the public reaction. We knew there was going to be some backlash from privacy, activists and other things. We knew that, at the time we started the project, there was not enough storage space in the entire world to accommodate the data we would need to collect. But we figured that there was a chance that, with increasing capacity in cloud compute, we would be able to get there. So it was really, it took a number of years to unfold. And yes, it's incredible that we're able to get to where we are today. I think you're right that when I left, we had 75 countries or so. Now they're probably over 100. But now I think the lens has changed a bit. I think early days, it was all about geographic expansion. I think now it's more about refreshing the data where there's most value to the company and to users, which typically means refreshing quickly in areas that urban cores and areas that change a lot. And country roads, we don't need to collect very often. So so it was an amazing experience.
That's extremely interesting, especially that you are building to the projection of where the technology will be. The data storage and the compute didn't exist yet, but you're like, well, at this rate, it'll probably exist at the time that we want to scale it to the level that we we foresee. I wanted to go over another really interesting project that you helped lead at Google, which is the acquisition of reCAPTCHA. And so if anyone in the audience has had to fill in the squares of streetlight or car, prove to a robot that you're not a robot, I think you have Luc to partially thank or blame for it.
Or blame.
Yeah, one way or the other, but it's definitely something ubiquitous in a lot of people's lives. And I'm curious, because when I see something like that, I just think about Google getting a lot of free data labeling for for training their models. Was that a factor at all in the original kind of acquisition? As Google's been very clever about using these different smart ways of getting people to label data or to give it new data. Was that one of the motivations or part of the
great question. So that was my vision. So when we acquired it, the acquisition was driven by the Google Books team, which was still had a foot in Google Books at the time. I think the M&A was in 2006, maybe around that, maybe 7, I forgot. But the notion was that using kind of a human in the loop approach, right, to OCR through reCAPTCHA, you would present to a user 2 twisted letter things, words. One being an actual CAPTCHA word, which you need to get right to get access to a web resource. The other one being pulled from, a scanned, in that case, newspaper, and typically a very crummy looking word, from a low quality scan, that newspaper, the ink had bled. So very hard for OCR system to recognize at the time. And again, you could ask a user, right? And the idea is that you would take that word and probably end up having an approach where that word is shown to more than one user. So once you have, maybe it says you show it to 5 users and 4 of them say it's that, you're pretty sure it's that, then you can do it. But I already thought that, hey, if we do it for words, we could come up with approaches where that kind of system of human in the loop could scale to allow for different types of labels from users. So we all this, it's an interesting story. So because the acquisition, the M&A was driven by the books team, that team went to books and was focused on books. But because of various reorgs at Google, the team didn't really get leverage as well as they should have been, and they were like sort of withering away. So I realized that at some point and made a kind of a case to bring them back to sort of my world, Street View in particular, right, where I figured we could use them to help create training data for some of the models we're starting to think about. And specifically, the first thing we did with them was to apply reCAPTCHA to street numbers or house numbers in particular. Pulled from using early computer vision models, pulled from from Street View images. And we would then again get reCAPTCHA users out there to help us transcribe those and build our models to eventually be able to transcribe multiple billions of addresses around the world, which themselves then became useful to build maps, to geocode, because the way you geocode, the way you take your application like Google Maps, you type an address and you get exact lat long, is because you've seen this address before, right? So that data, we help create the first sort of automation pipelines for this, thanks to reCAPTCHA. And now, as you've seen, reCAPTCHA has expanded. We actually expanded that under my watch, so probably back 8-9 years ago, to the grid of images you now see, where you're asked to tap on images that contain a boat, images that contain whatever, and that again is used for training various recognizers at Google. And that was fun. And the volume, is so large that even though there needs to be some replication, you can't, trust one single user on the web. The volume is very, very large. So the data is, invaluable to Google.
Yeah, so you can probably tell, hack is you can tell what kinds of models engineers at Google are training based off of what you're, answering in the reCAPTCHA. Next will be some new set of things which will probably be harder questions to solve than object detection and street signs and cars. So one way for the have a glimpse into what Google researchers are thinking about.
Well, maybe I think it's a bit more nuanced than that. You can't make it too complicated for users, or they're just like, okay, forget that. So you got to find the right balance between, the complexity of the gaining access to a website while not, having the user have to spend 10 minutes to click on things or tap on things. That's kind of the challenge.
Yeah,
in some situation, you actually want to remove the CAPTCHA. You have enough signals from whatever the IP address, other things that you let them in, right?
Yeah. So I wonder if the next layer will be, chat responses. to say whether this is a good response or not, to retrain the Google Bard system. Maybe that'll be the next recapture.
Quite possibly.
It's interesting because we see, what year was this that you were doing?
That was probably 8 years ago, 8 to 10 years ago, roughly.
Yeah, so we're seeing the same kind of mindset now within some of the AI companies that we're working with. But it's really interesting to see that you guys were essentially a decade ahead of this kind of full human in the loop, active learning, retraining, annotation pipeline, and you were able to really master it at scale, which is quite impressive. And it seems
thanks. And by the way, so this was just one of the systems, but obviously reCAPTCHA is limited in the spread of tasks it can do. It can't do everything. So we also built other systems in house, which were more like annotation platforms. One we built, there was like multiple generations of it. The latest one is called Cloud Compute. I think it's still being used at Google. It's now part of Google Cloud, but I'm not sure. And it resembled, kind of the kind of thing that many AI annotation providers out there today offer as a service. Same idea.
Yeah, and part of the need to annotate all this data is the data hunger of a lot of these deep learning systems. And I think you were at Google when the first deep learning revolution went through and the AlexNet came out. What was that like? Was it a sudden shift from kind of these older heuristic methods, as you mentioned before, or was it kind of gradual? Was there pushback against it? I'm just curious how deep learning propagated internally.
Great question. I think they were like there were those people that were believers, typically more like the engineers that had been in that field or in for some time and knew that there was something really disruptive here. But they were the skeptics, I would say. And I was part of the broader Geo team. And one thing that in particular we tried to advocate for is building maps automatically from imagery, right? Imagine that the imagery that you collect from Street View in particular, from Street View or from air data and satellite data, that's ground truth. It's stuff you've seen, you've observed, right? And so it wouldn't be awesome to take that and derive knowledge from the world, from this imagery. Again, starting with, as I mentioned earlier, the house numbers, but going much beyond this, going to street names, lane configuration, even recognizing businesses in the street, and everything else. So that was kind of the vision, but it was early days. The tech was still evolving rapidly. The models were rudimentary, so we had to train on gargantuan amounts of data. So it was not fully proven yet, but it was certainly promising enough that we invested in this. Now there were some skeptics, people who said, well, sure, you can build a system to recognize house numbers, but how about we just build instead, we ask a user, right? So they were like competing forces, people who believed that what we call UGC, user-generated content, was the answer for everything, right? And some like us, we were, I think, a bit more, when I say us, I mean my org, and engineers that had kind of a deep understanding of this tech. We've believed that a more nuanced approach and maybe more algorithmic heavy was going to win in the end. So I think, I don't know, what's happening at Google today, but I suspect that, a lot more of the map now is built through, AI. Maybe they'll talk about it at some point.
So did you see the time? How long did it take for the skeptics to concede, or did they never concede, and it was just kind of a ever shrinking pool of people and work?
I think there's still that even still today, I'm guessing at Google, there's this tension, right? I mean, if you think about it, for the longest time, I think the Google search engine was itself was purely it was not AI driven, right? It was purely based on a bunch of heuristics, right? And why? Because it was felt that you could debug, you could understand why the system gave you that answer. And going to a black box, AI system was seen as too risky, too difficult to scale. But I think now it's pretty fair to say it's purely based on AI models, or at least in large part. So
yes, that's actually a great point to transition to the next point of your. It was also very fascinating. So you led the AV division at Lyft, and one of the major pushbacks towards autonomous vehicles is that it is a black box, and one which is quite important. It has safety concerns, and how would you generally respond to people's precautions around the fact that you can have vehicles on the road that are driven by systems which are difficult to explain from a human perspective?
Yeah, so maybe stepping back before I answer that question, I think I came to Lyft to found the Lyft Level 5 division. Lyft didn't have one before I came, and the reason I was interested and I thought what that was useful was that first of all, I believe that a platform like Lyft would let you deploy AVs incrementally, right? Without having to solve a massive ODD or a very large geographic coverage challenge from the get-go. You could imagine AVs operating on the Lyft platform alongside drivers, and initially the AVs would be very limited in their routes. They maybe do one route or two routes, and eventually as their capabilities increase, they could do more. There was also the data piece. Lyft has, and these other transportation services have lots of cars on the road, and you could imagine having these vehicles collect data as part of their operation, right? And so we felt that there could be a situation where tens of thousands or more of Lyft vehicles on the network could be collecting data that could be used for training these systems. So again, that implies an AI system, right, for the self-driving car, and a AI system that would be AI sort of all the way. I think if you look back at 2017, which is when I joined Lyft, at the time probably there was a lot of excitement in self-driving, and many companies making bold claims as to when they were going to launch their service, because it was going to be because they were almost ready. They thought they were almost ready because they had solved essentially perception. But hey, it turned out that perception is only one piece. The most complex is probably the decision-making logic that you need, right? To and these systems that had been built early on were very heuristic, I would say, very robotic, based on rules, and so that's why I think that couldn't generalize, and these companies didn't launch their service until 4 years later, still at small scale. So AI, I think, was like the key. And going back to your question, so we envisioned like a full AI system, end to, not necessarily end to end, maybe multiple models, but cascaded, to sort of be the driver, quote unquote. And indeed, when you have one of these systems, as you very well know, understanding why it made this decision is very tricky. But I think, honestly, the heuristic system that other companies may have are getting to be equally complicated and equally hard to debug. Understanding why something happened becomes very difficult. So ultimately, I think it's going to be about validation, verification, and it's going to be about being able to prove over very large data sets that sort of statistically you are a lot safer than a human driver, right? But that will take time, I think, to let the public understand that, and we are just at the beginning of this. I think so far we're seeing some success by Cruise and Waymo in SF and maybe a few other areas, but it's still early days, so we'll see how that unfolds.
What do you think the balance is between companies that are taking the more heuristic-based approach versus ones that are going for kind of full end-to-end AI? Is it split, or is that changing as well? Is there a dynamic there that's interesting?
It's hard to tell. I mean, they are all very, very secretive in their approaches, right? But I mean, there's one company in neck of the wood that's been taking a AI approach, from the very beginning. That's Wave, right? I think they are interesting, but still early days. And there are others taking these kind of approaches, but I think the big ones don't really talk about, their systems. So it's hard to tell exactly what's going on, within the company. I can speak to it. Yeah.
And do you think this mismatch between the original expectations and what ended up realizing was this kind of decision-making difficulty, or were there other factors involved that were blockers to getting self-driving proliferated out more generally?
I think, generally speaking, that's that. It didn't work well enough yet, right? Again, when perception started to work, for a long time, if you think about it, outside, well, or maybe even within, the self-driving world, people equated the complexity of self-driving with perception. That's why you saw all these papers, all these, anytime you talked about self-driving car, you saw a street scene with a bunch of bounding boxes, right? And once that started to work well in all weather conditions, right? Again, thanks to deep learning, and I think people, even insiders, thought that the rest would be simple and a matter of tweaking the system a bit. But it turned out to be far more complicated than people expected. So that I think is why it took a lot longer than they expected then.
And what does the data look like for training those kinds of systems where you have to make an action? It sounds like a reinforcement learning process or problem. How do you set up a data pipeline that works and then also talks to all the other components? It'll have to talk to the perception system and the hardware. Do you have any kind of insights into the kind of general challenges there and thoughts on how it works?
Well, I think probably people have different approaches, today. So I can't speak to it in general. I can say that what we tried to do at Lyft Level 5 was sort of, come up with a data representation that was bitmap based, right, to train on, right? And you're right, there's like a lot of reinforcement learning and things like this that went into it. But I think it comes down to what is your representation that you learn on, right? And how do you also, sort of measure performance, right? The problem is that there's, for any kind of situation, there are usually very many, good paths through the data, right? And so it's difficult to, even if you observe human behavior, the human may have done the safe thing, but it was maybe not the best thing to do. So I think that leads to very, big challenges, on how to train on this. I'm not, an expert at this. I can't really speak to it, but these are the things we're trying to address prior to us eventually being acquired by Toyota.
And do you have a view of when you think? I mean, it's a very difficult question. I don't want to put you on the spot, but when autonomous vehicles will be kind of wider used in the public, maybe parameterizing by 10% of the vehicles on the road will be self-driving. What the timescale for that looks like from your perch?
It seems like it's always been 5 years out. I think it's going to be more than 5 years for sure. Right now, it's a tiny fraction, right? And I don't actually know what the ultimate sort of percentage will be. I think it is possible that we'll get in a situation where let's say rideshare service as you know them today will be mostly robotaxi plus some human drivers to complement them, to do rides that are still too hard or unmapped maybe for robots. So maybe the majority of the self-driving will be on these platforms. I don't think, my personal opinion is that self-driving is especially suited for these services, but there's maybe less of a fit for personally owned vehicles, although I could be proven wrong there. So what's the ultimate number of self-driving cars we'll see on the road, percentage wise? Yeah, maybe 10%. It's very hard to tell. But no matter what, we're very far from that. I don't think we've reached any kind of what we used to call commercial scale with these services, robotaxi services. So commercial scale may be still 5 years away, and 10% of the cars on the road being AVs will take another 5 or 10 years. So we're still, I think, early days on this.
So some significant percentage. at least 5 years out, which I think is a good sober estimation. Some people they always say 2 years every 2 years. That is always 2 years.
That's
away.
right.
So after the L5 division was acquired by Toyota, you joined Meta, and I'm curious, as much as you can talk about what you're working on at Meta now, curious to get into that as well.
Yeah, totally. So again, after the acquisition was over, I actually got approached by Meta and got interested in the space of AR in particular. And what struck me, in fact, I want to show you right now, AR glasses. So these are, well, they are not actually technically AR glasses, right? They are smart glasses because they don't have a display. And in fact, they can't show you. AR glasses would be able to show you information overlaid and locked in the real world. These are don't have that. In fact, battery, they don't have a display. 100%. Oops, tiny battery, 100%. If you heard that. So, but they can do a few things. They can, they have sensors, they have, microphones and cameras. So I thought, hey, these glasses, well, they're a bit like self-driving cars, right? They are egocentric sensing platforms. They're also multimodal. And you have to use that egocentric sensor data to help a user do interesting things. So in the case of self-driving cars, you help a user, go from A to B. Here, I think you want to help a user do a whole bunch of things throughout their day, help connect them, help protect them, help empower them, all while being present, right? I thought the challenges of that were similar, maybe even more complex than in the AV space. But again, the difference being that you can't really the safety aspect is taken care of. You can't really hurt somebody with these glasses. So that what attracted me to it. So I'm working on various I would say multimodal AI systems to help understand context, right, and then help the user in the moment while being present. So I think the idea is that these glasses, once mature, I think we're still very far away from that, but once mature, right, you'll be able to do with them things you do on your phone today and more, such that you can actually be present in the moment. You can, for example, take pictures without taking your phone out. You can do a bunch of things, to be more connected to the world, right? And that's kind of the vision for this. So a very exciting space. And I'm going to take a picture of us right now. See, look at that.
Yeah.
Hey, Facebook, take a picture. Here we go. I took a picture. Pretty cool, eh?
So it has a recorder, a camera, and then the kind of display it will be in the kind of next generation or a couple of generations.
At some point there'll be displays. I mean, there are today some AR glasses in the market that have a display, right? But they are, first of all, they are very more expensive, right? And they are very bulky. These are made by Ray-Ban. They're called the Ray-Ban Stories. They're actually pretty stylish glasses, right? So they are cool. Other glasses are not things you might keep on your nose all day long. I'm going to put back my regular glasses because these actually have correction.
I've never heard anyone compare Ray-Ban glasses to self-driving cars before, so I think that's a first. And how would it work for people that don't wear glasses? It'll just be clear lenses, and do you expect a world where most people have the glasses on, or do you expect a world where it's fewer people and they use it in certain occasions? How do you think the usage will actually look like in the real world? Yeah,
great question. So I think if we are able to bring in a value, make them so useful, probably everybody will want one. Just like everybody has a cell phone now. That's kind of the vision. You make something so useful that people will want them. If you don't need corrective glasses, I mean, these actually don't have correction, right? But they darken, in the sun, so they're useful as sunglasses. So you still wear them probably. And again, if they bring in a value, you'll do it. That's the idea. There will also be ways to, of course, to put corrective lenses in there, and so that's the goal.
So it seems like there's multiple challenges from an AI perspective. You mentioned multimodal because You're probably seeing the audio information with the video information, the kinematics, the movement of the person. One kind of non-trivial thing from my perspective is, what does the objective function look like? What are you trying to optimize for glasses being used by people? If it's a perception problem, you're trying to get the computer to understand, oh, that's a car and that's a dog, and all these things have bounding boxes. But what is the purpose of the AI? What is actually trying to optimize towards? Or is it many different sub-objectives for this particular problem?
Yeah, it's many objectives, but the idea is to help you do a bunch of tasks, right? From taking pictures, calling on WhatsApp, being able to take action on objects, discovering things around you, doing navigation. So there's a whole bunch of things that you can do. And so you point your finger on the challenge. How do you do this in a way that's sort of efficient? I would say there's like three main challenges with these glasses, right? One, first, the form factor. I mean, this is like, highly constrained, right? You have to cram a huge amount of tech in these glasses, from compute to, batteries, to, RAM, to, a bunch of sensors and what have you, right? And do it in a way that still keeps them looking good and being light enough, right? And obviously you have to do it also in a way that, you have to worry about thermals. It's pretty highly constrained. So again, you don't want to burn the user. So there's a whole bunch of things that are very complicated by the form factor, right? That's one. The other thing I think is like the data, right? To train, AI models to do things, you need data, and that data here doesn't really exist. We want to imagine this. We want to have be able to understand the user's context. Are they, like, for example, are they cooking? Are they are they, I don't know, going for a run, or other things? Are they inside, outside? And from that context, be able to again help you with whatever it is that you might need help with at the moment, right? But that data doesn't exist because these glasses don't really exist yet, right? So I mean, so we're trying to bootstrap this, in many ways. One thing that we have done, for example, is our research team has started a project called Ego4D, which you can look up. And Ego4D is kind of a consortium of universities, 12 or more around the world, that are collaborating on egocentric multimodal perception, if you want, right? That are sponsoring data collection, that are creating various contests and ways to evaluate sort of algorithms. And the data is actually annotated by Meta. So Meta, annotates that against maybe 5 different classes of activities, right? Such that then we can run benchmarks of various kinds with our partners. All that data is actually publicly available to consortium members and beyond. So it's very exciting. It's already like a very large amount of data that Ego4D has produced. We have also, so Ego4D is only about camera data, so visual data. But as I said earlier, these glasses have many other sensors. And ideally, you'd want to use all the sensing you have to get kind of a better, higher performance model, right? The models should be able to use, sound, information, visual data, IMU and others, right? To sort of trigger the experience that you want. And so in order to do that, we have also created something else, which is these glasses, if you see that. So these are Project Aria glasses, right? Also created by our research team. They are not a commercial product. They are not an end user product, but not a prototype either. They are actually a data collection device, right?
Interesting.
They are crammed with sensors, from cameras to eye tracking cameras to, 7 microphones and what have you. And we have a bunch of volunteers within Meta, about 1,500, I think, right now, that are using them for targeted collection tasks. For example, we may tell them, hey, we need more videos of people cooking. Can you wear the glasses while cooking? And record like a half an hour of data or an hour of data, which is unused and annotated and used to train models. So that's kind of the data piece. So the form factor, the data, I would say that the last huge challenge with these glasses is how do you interact with them? They don't have a keyboard, they don't have a mouse, they don't have a kind of a touch screen. So we think there's like three ways that will be, that are worth exploring. One is, of course, voice, where, today, we are using kind of a voice assistant interface to these glasses, which is good, is useful, is great, especially when your hands are tied, but it may be awkward in some social situation to talk to your glasses, right? So we are, so there's one more thing that could be interesting, which is something called EMG, or electromyography.
Oh, wow.
Essentially reading electrical signals produced by muscle activity, right? That could be, so that Meta acquired a company called Control Labs about 3 years ago that is working on this, and ultimately that could help you maybe control your glasses. But I think the biggest opportunity is also in proactivity. And so the idea is to build models that understand your context deeply from multimodal egocentric sensing, right?
Mm-hmm.
And then are able to trigger the right experience at the right time. And these models need to be probably multi-output, so they multitask, in part because the glasses are so constrained that you have 5, 10, 20. If you have more and more models based on the different things you help users with, it won't fit. It will be too much memory. It'll be too much compute. Resources. And the glasses are limited. So you have to be very thoughtful. And I think a design that is worth considering is building what I would call trunk models that are multi-model, multi-input, multi-output, and then building your experience as a thin layer on top of that. So that's what we're working on.
That's all like extremely fascinating, and I don't think there's a large body of research in this area. So you guys are, it sounds like you're pioneering a lot of the research, especially with the lack of data that's available. You have this new kind of data collection venue. It strikes me that one of the themes of your career, just looking back, is these clever ways of getting data acquisition. So using reCAPTCHA to get a bunch of people to label your data, and then using the Lyft fleet to getting a lot of data, and now using people wearing these meta glasses is another way of getting data. So the key is really finding smart ways to get data and then use them to train really interesting models. I'm curious on the kind of muscle contraction, if a plausible future of the world is that we control our phones just from flexing our muscles or doing minute bodily activity, and that will kind of move a mouse around or do selection. Is that something which is something which could potentially happen in the future?
Yeah, potentially, right. Yeah, so again, it's hard to predict how that's going to go, but this is certainly something that is worth looking into. And I think there's also other companies looking at this kind of neural interfaces. So we'll see. Nothing is proven yet in products, but it's definitely something that's interesting. So yes, that could be a future.
Do you have a timeline that you can share of when these things are going to be out in market, or is there a bucket or a scale?
Yeah, I can't talk about it really. So we besides, I think nobody really knows for sure. So
yeah, that's definitely fair. So we've covered the past and the present. What excites you about the future of AI? I mean, a lot of the things you're working on now, it's quite exciting to me. Is there anything else that is particularly striking to you?
I mean, I think what always excited me in my career is to build a product that is used by billions of people or very large numbers. So I think that happened, for example, with Street View. I think we had certainly billions of users. Well, over 1 billion. I don't know exactly how many billions, but a very large number. I think here, if you look at cell phones, I don't know how many cell phones there are in the world, probably 4 or 5 billion. And if we succeed with that tech, if we're able to make the glasses even more useful, imagine the potential. So that's what excites me. I think being able to help large number of people, throughout their day, be more productive, more connected, and that is what I think is very, very exciting.
Yeah, no, it's very nice to lay down a bed and I know that you've created tech that has influenced billions of people in the world. I think that's something which is quite cool. I would also be remiss to ask about what you think about generative AI and ChatGPT and all the things that are coming out in the last few months?
Yeah, it's only been exciting to watch and to see what happens. So I think OpenAI certainly has opened everybody's or many people's eyes as to the potential for that tech. Now, is ChatGPT a real product yet? I'm not totally clear. It's certainly exciting and fun to try. We're seeing probably some overreaction from many of the big tech players out there in coming up with a strategy and a reaction to ChatGPT. So certainly it's lit a fire under many companies, big tech, as well as other startups, sort of trying to latch onto the Gen AI craze and raise fund and build new products. So probably we are, again, I'm just speculating here. What do I know? We're seeing like a huge amount of hype right now. It's likely going to die down a bit. Like it was any kind of cycle. There's like a big jump, and then there's going to be a trough, and then eventually it's going to lead to amazing products. But right now we're in the phase of crazy hype. So we'll see how it plays out.
The cycle of life of technology.
Exactly.
So we do have people submitted a bunch of questions for
Okay.
Q&A. So I want to take the last minutes for that as well. So one of the questions that we have, we touched on it a bit. What's the biggest obstacle to computer vision applications in autonomous driving? Sounds like the decision-making process. Is there anything else to touch on from that? Well,
I think, yeah, I think I would not think of autonomous driving as a computer vision application, right? It's much beyond that. So again, if you think of perception alone, it is computer vision. But yeah, as we touched on, I think the decision making, the planning is the biggest trend right now. And the question is really, are we going to be able to see end to end or mid to mid type of approaches that surpass all these robotic hand tweaked methods? I think we haven't seen that yet, but it'll be exciting to see how things evolve over the next few years.
Yeah, that makes sense. One good question: what advice do you have for individuals who are interested in pursuing a career in computer vision, and what skills and qualities do you believe are essential for success in this field?
Gosh, I don't know if I can be that insightful there. I think first of all, I would certainly think that getting your hands dirty, by trying various models and getting to tangibly understand their pros and cons would be very important. So I think right now many of these models are open source. There's like a lot of things you can do very, very easily. So get your hands dirty, try things, get a tangible sort of understanding of how these models behave, what happened when you change the training data, when you add more, when you add less. I would sort of do that. And certainly, again, there's like many awesome tutorials now all over platforms like YouTube and what have you. So I would certainly, depending on your level of, where you're starting, if you're starting from scratch, go and take some of these classes online. That would be a great first step.
Yeah, there's so many ways of just going in and training a model from scratch and building the intuition, as you said, of what works, what doesn't, what matter. So yeah, I would definitely agree with that. There's a question I don't know as much as you can answer. Will Meta launch something similar to GPT?
I can't answer that question, obviously. So, but I can say one thing. Meta has launched various large language models, at least two recently, right? But they were, I think you should search for comments by my colleague Jan LeCun on various platforms from LinkedIn to Facebook. He's highly opinionated about this, and so you think that I think the reason they may have been less well received, that they were too safe. There's no way to sort of veer into more, I would say, controversial topics without the bots. I can answer that question. So I think that's where maybe ChatGPT was tweaked differently. But that's just my opinion. I would say I would look at Jan's comments.
Got it. Yeah, that's good for anyone in the audience that is curious and following up on that. How can we restrict wrong use of AI? Do you think the community is mature enough to accept and right approach? Is AI growing super fast that the average global community can get it corrected? So there are some, I think, grammar issues with the questions, but maybe how can we restrict wrong use of AI is like the main thing to kind of center around.
I mean, I think that's a big topic, and I don't know that I'll have deep insights here. I think responsible AI is a big topic that I think every sort of big tech company right now is grappling with. How do you make sure that you have had the right, you don't have any bias in your data, in your in the sort of the output of your system, right? How do you make sure that the system is safe, right, to use, not discriminating? So these are all the questions we're all grappling with right now, and that's why I think the systems that are live have very strict guardrails, right now, but are still evolving. And as we've seen many articles about ChatGPT, and there is a way to if you have a long enough conversation with ChatGPT to get it to a point where it's behaving very, very weirdly. So I think we haven't solved that yet. I think this is still something that as a community of scientists and just thought leaders will need to address, and it's going to probably play out over a number of years. I don't think we've solved that yet, but it's a very interesting topic for sure.
Yeah, definitely. It'll definitely be something which comes up a lot more in wider conversation as the technology evolves and matures. And the community is also very lucky to have you as a member of it. And I want to thank you for for all the time and the stories that you've shared. You've been a part of some very, very cool things that have touched billions of people, and I'm very excited about the new projects and initiatives that you're running. Some of the ones that we talked about today. I definitely want a phone being controlled by my muscle movements. I think that will be quite exciting. So thank you, Luc, so much for your time. We really appreciate the consideration and the conversation. And thank you everyone else for joining today and for your questions. We look forward to future chats and have a great rest of the day. So thanks so much, Luc.
All right. Thank you so much. It's been a pleasure. Bye, everybody. Have a great day.
Bye.